Question number 30. The unstretched length of the spring is r when P in P is in an arbitrary position theta. Determine the x and y components of the force which the spring exerts on the pin. So from here to here is 2r. From here to this point is r. Therefore, from here to here is r. Okay, for finding the force that is exerted on the pin, we need to find the length of the spring after the pin is coming to this point or any arbitrary point. So let us find it out. So we have a triangle here. From here to here is 2r. From here to here, OP is r. So we can easily find this out by cosine rule. Let us do this first. So AP squared is equal to OP squared, which is r squared, plus 2r squared minus 2 this side and this side. R 2r cosine of theta. Okay, 2 squared is 4, 4 plus 1 is 5. 2 times 2 is 4. So, okay, now r squared will be before the parentheses, 5 minus 4 cos theta. Okay, if you now take the square root from both sides, this side will be AP equal to r the square root of 5 minus 4. Okay, here I should remove the r and it will look like this. In the next part, we will use the sine rule. So sine theta, and this is AP bar, this length. Let's make it bigger. I will call this angle alpha. And sine theta, actually this angle also will be, so since it is theta, this is 90 degree, and this will be 90 minus theta. So this big angle is, or OPA, is 90 minus theta plus alpha. So we need to know the amount of each angle for all of the three corners of the triangles, and then we will put them in the sine rule formulas. So this, in front of this angle, we will have 2r. This one is r, OP bar is r, AO is 2r, the length, and this one we have already obtained it in the previous section, AP bar I mean. So we will put them in the formula, and we will use sine inverse from both sides. Sine and sine inverse are inverse of each other, so they will be, the right hand side will be this 90 degree minus theta plus alpha. And we also take the sine inverse from this side, which will be this. So alpha will be, we can just take this and we will put it on the other side. It will be sine inverse of 2r's this amount, whatever. So we have alpha here, and we know that F is for a spring is equal to K, the stiffness of the spring, times the difference between the unstretched length and the length that we have now. So we have already obtained this part in the previous section. It will be my unstretched length is R. A lot of people forget this. Don't forget this. So Fx is, so the x direction is in this way. So the important thing is you need to know the direction of the force when you have a spring in these questions. So it will be in this direction, not the other way, because when it is extended, this will be stretched and this pin will be pulled. So F is in this direction, Fx will be in negative direction of the x, and Fy is positive. So we will put the sign here correctly, and this is cosine alpha because the angle with respect to x-axis is alpha. We will, in the question it says that the stiffness is around 1.4 kilonewton, 1.4 kilonewton, which is equal to 1400 newton per meter. K here means 1000, and R is 40 centimeters, I think, or 400 millimeter, which is equal to 0.4 meter in SI unit. So you will put SI unit here, and the angle is 40 degree. So we just put here 40 degree. But we don't know the amount of alpha. Here we will obtain the AP bar, and we have theta as 40 degree. Okay, now first find the AP bar. So I want to tell you one trick in the exam. First, always try to make sure that your scientific calculator is working properly. Use 60 degree and then obtain the cosine. It will be in 0.5, which is correct now. Okay, now let us see how to calculate this part first. So we will just type first 5 minus 4 times, not cosine, first 40, and then trigonometry cosine. So this is the amount of cosine, and then you will just equal of, so this amount is 5 minus 4 cosine 40 will be this, and then you will take the square root, which is this, and times 0.4, which is 0.557, not 6, because this is 5. And you need to put the unit, which is meter, because everything is in SI units. And we will copy this. Okay, for obtaining alpha, we need to use this formula. So I will copy this again here. So this is 0.557. This is 40 degree. And 2 times 0.4 is 80, but I will just keep it as it is, and this is also 40 degree. For obtaining this part, first obtain this 2 times 0.4, which is now 0.8. The 0.8 times 40 sine equal divided by 0.557 . So we need to find the sine inverse of this degree. Let us first write this 0.923. So alpha is equal to the next line, and 14 and minus 90 will be 50. Okay, for inverse sine, we need to click on second here, and now we will obtain the sine, which is 67 degree minus. Okay, now to obtain the sine inverse, it should be 67.4 degree, or pi minus this, which will be 112 . .6, and also we have minus 50 . So here alpha will be 62.5, and here it will be 70.4. So if you consider this as an answer, we'll also change this 62 point alpha here. Okay, let us calculate this. Cosine of this is 0.46, and we have already obtained this, I think. Okay, let us go one by one. So 5 minus 4 plus 40. So 4. 40 and cos here. We choose cos here times 4. Okay, and the square root of this which is this times 0.4 minus 0.4 times 1400 . Now we need to keep this number 219 blah blah blah, and cosine of this number, which is, we're gonna write it and put times 62.5 cos 101.2, but we also have a negative sign here. 101.2. Okay, the next one is easy. Fy is 290 19, and this one also will be 219 times sine 62.5 degree, which will be 194.4. Now my question is, why alpha cannot be this number? Actually minus 50, I forgot. Yeah, this 17.4. Answer me this question in the class.